Skills assessment, this topology. Start all devices. First of all, configure R1. Enter configure terminal hostname R1. No IP domain lookup. This is the basic configuration. Now configure interfaces. Gigabit 00, IP address 225, subnet mask 29. Interface gigabit 00, IP address 225, subnet mask 248, that is 29. Now shut down. The serial interface, in my case, 31, but it's serial 001. In my case, 31. The IP address is 233, subnet mask 30, 252. Now shut down. And you need to create a static route on R1 to reach this network, the LAN on R3. Exit IP route 172.16, 30.30.24, and use the NetHub IP address as the 234. Okay, R1 should be the NTP master for the to later configure the client, the NTP client. Okay, but the configuration for the NTP master on R1 should be the following: NTP authentication key number 1, use MD5 and use the following password: NTP uppercase and password lowercase. NTP trusted key number 1 and NTP authenticate NTP master 3. The stratum. Okay, this should be applied on R1 because R1 should be the NTP master, the NTP server. Okay, but for now, do not apply this because GNS3 has some issues with NTP. Now configure the R3 router. Configure terminal, hostname R3. Now IP domain lookup. Gigabit 01. But in my case, I'm using 10. Interface gigabit 10. The first IP address on the subnet 172.33.1 and 24. Finally, no shutdown. No shutdown. Serial 30 interface is serial 000, but in my case 30. Serial 30. IP address 209.165.200.234. Subnet mask 30.252. Now shut down. Exit and finally create the IP default static root, the quad 0, and use the to reach another networks, and use an ad hoc IP address 209.165.200.233. The interface placed on R1. S1, configure terminal, hostname S1. Now IP domain lookup, spanning tree. For VLAN 1 should be the root primary. Okay, S1. Enter. Okay. S1 should be the root primary. And shut down all unused interfaces. Okay. On switch 1, the unused interfaces are the range is from 1 and 2 in use, and Fast Ethernet 3 to 5, because 6 is used for the PCA, and Fast Ethernet from 7 to 24, and Gigabit 0, 1, and 2, because this is a 2960 switch. S1 is a 2960 switch in a real lab, and these are the unused interfaces. Okay, so you can apply this on a real lab, but in my case, I will use a Linux device. Still is not started. Okay, but I will place it on Ethernet 03. PCA in this case. Windows PC for S2, connected to S2, that will be PCB. Windows PC is necessary to configure ASA using ASDM. Okay, that's why you need a Windows PC 03. Okay, very good. Now here, PCC, another Linux .03. Okay, IP address number 3. Okay, on S1, shut down all unused interfaces. Okay, add show running config. .0.0 is not in use. 0.1, 0.2, 0.3 in use, and 1.0 to 1.3, 2.0 to 2.3, and 3.0 to 3.3. Configure terminal interface range Ethernet 0.0 to Ethernet 0.1 to 0.3 in use, so 1.0 to 1.3 not in use, Ethernet 2.0 to 2.3 not in use, Ethernet 3.0 to 3.3. Shut down interfaces. And the same process on S2. Configure terminal, hostname S2, no IP domain lookup, spanning tree for VLAN 1, root secondary. Okay, that is enough. Do not disable the unused interfaces here. Okay, all previous configurations are here. R1, the configuration of interfaces, the static root, the NTP master configuration for R3, the interfaces, default static root, basic configuration on S1, on S2, PCA, PCB, and PCC. Okay, S3 should be any switch. It's not necessary to use a 2960 switch on a real lab, or maybe this switch IOU L2 on GNS3 or VIRL. You can use any switch or connect the PCC directly to R3. Okay, so this switch can be ignored. Obviously, you need to modify the number of interfaces according your network, according your devices. Okay, all this should be provided by your instructor, or you can configure all this. Verify network connectivity. In the interest of time, your instructor has pre-configured basic settings on R1 and R3, and the static IP addresses information for the PC's host and the topology. You will verify that PCC can ping the gigabit 01 interface on R3. Okay, start PCC. Configure the IP addresses and the default gateway. One 160, 172, 30, 33, 24, 172, 30, 31. Okay. Save. Restart networking. Ping gigabit 01 interface on R3 from PCC. We go to command line. Success. Control C to stop. Ping serial 1 interface on R1 from R3. Okay, go to R3 and ping serial 1 on R1 233. Success. And also, PC should be able to ping serial 1 on R1. Okay, success. Ctrl+C to stop. Configure secure router administrative access. Set the minimum password length 10 characters. Okay, only on R3. Configure terminal security passwords min length 10. Assign and encrypt a privileged exit password. The password is Cisco 12345 and the encryption type 9 script. Enable algorithm type script secret Cisco 12345. Okay, this is the correct command. Enter. Okay, this algorithm is not supported by iOS 15.0. This is my case, but is supported by 15.4 and later. Okay. I will use the enable secrets command. Okay, but this is the correct answer. Next, add a user in the local database for administrator access. User admin01, case sensitive, privilege 15, encryption type 9 script, password admin01 pass. Okay. Username admin01, case sensitive, privilege 15, algorithm type script secret, and the password is admin01 pass. Okay, username admin01, privilege 15, algorithm type script secret admin01 pass. Enter. Okay, this is the correct command, but again, the algorithm is not supported. So I will use the username admin01, privilege 15, secret admin01 pass. But this is the correct answer. Banner message of the day. Enter. Disable HTTP server services. No IP HTTP server and no IP HTTP secure server. Okay, disable HTTP and HTTPS. Configure SSH. Okay, IP domain name CCNA security.com. Okay, the key 1024. Crypto key generate RSA modulus 1024. Okay. Version 2 timeout 90 seconds. IP SSH version 2. IP SSH timeout 90 seconds. Okay, use dash. And authentication retries to IP SSH authentication retries to. Okay, but on the VTY lines, allow only SSH. Okay, line VTY 0 to 4, transport input SSH. Configure AAA authentication and authorization settings. Enable AAA, exit, AAA, new model. Use local database as default settings. Okay, that's why I'm not using the login local command on the VTY lines, because when you apply the use of local database as default settings, we'll use the local users from using AAA. Okay. Okay, and verify. Show running config. Okay, AAA new model. Okay, configure terminal. AAA authentication login default local. Okay, use local database as default settings. AAA authentication login default local. And also says authentication and authorization. So that's why you need to apply the authorization command. Authorization, AAA authorization, exit default local, default settings. Very nice. Finally, configure the NTP client. So I will insert the commands on the notepad. Okay. This was for the master, the NTP master, and this will be for NTP client. Authentication key, NTP password case sensitive, NTP authentication key, key is the number 1, okay, 1, and use MD5 encryption, MD5, and use NTP password. Okay, NTP authenticate. The server is this IP address 233. This IP, the server is R1, client R3. NTP server 233. Configure for periodic calendar updates, NTP update calendar. Configure syslog. Enable timestamp service to log the date and time in milliseconds. Service time stamps log date and time in milliseconds. Log date time milliseconds. Send these log messages to PCC 172.30.33. Login trap, login host, okay. Set message login severity level warnings. Login trap warnings, okay. Configure a zone-based policy firewall. Create security zone names. Inside zone, call it inside. Outside zone, call it internet. Zone security inside and exit, and zone security internet. Exit. Create an inspect class map. Class map name inside protocols. Class map type inspect inside protocols. Case sensitive. Match inspection type match any. Okay, so remove this. It's not okay. Exit. No class map type inspect inside protocols, and should be the following: class map type inspect match any inside protocols. Okay, this is the correct answer. Class map type inspect match any inside protocols. And allow TCP, UDP, and ICMP. Match protocol TCP, UDP, ICMP. Exit. Policy map name inside to internet. Policy map. The policy map is also inspect. Policy map type inspect. And use this name inside to internet. Bind the class map to the policy map. Okay, class type also inspect is called inside protocols. Case sensitive. Okay, inspect. Matched packets should be inspected. Okay, so inspect. Exit. 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 Verify. Show running config. Okay, the zones, the class map, and the policy map. Okay, create the zone pair, this name into out zone, configure terminal zone pair security in to out zone. The source will be the inside zone and the destination will be the internet zone previously created. Okay, the source is inside zone and the destination internet zone. The name into out zone. Okay. Enter. Okay, source zone inside, destination zone internet. Apply the policy map to the zone pair. Zone pair name into out zone, policy map name inside to internet. Okay, look at this. This is the zone pair configuration mode. Into out zone. Here apply the policy map. Service policy type inspect, and the policy map configure it. The policy map is called inside to internet. Okay, inside to internet. Inside to internet. Service for okay. Service policy should be policy type inspect inside to internet, case sensitive. Okay, exit. Assign interfaces to the proper security zones. Gigabit 01 inside serial 00 internet. Okay, gigabit 01 inside serial 00 internet. In my case, gigabit 10 will be inside and serial 30 internet. Interface gigabit 10 in my case. Zone member security inside and serial 30 internet. Okay, and verify some things here. For example, from PC3, from PCC, use SSH to access R3. Okay, PCC. The PUDI, the IP address of R3 172.33.1. Port 22, open, accept. Remember the user admin 01, case sensitive, and the password, and this password, admin 01 pass. Admin 01 pass. Okay, successful. Privilege 15, so that's why it's placed on privileged user exit mode. Show running config. Very nice. Exit. And for example, try to ping again to R1. 233. Success. Because some basic policy firewall is permitting ICMP. Secure layer 2 switches. Assign and encrypt a privileged exit password. Okay, on switch S2. Enable algorithm type script secret Cisco 12345. Okay. Okay, in this case is supported by my IOU L2 switch. Okay, very nice. Username admin01 privilege 15 algorithm type script secret admin01 pass. Okay, this is the username admin01 privilege 15. Okay, privilege 15 encryption type 9 script secret admin01 pass. Enter. Success. Message of the day banner. Disable HTTP and HTTP secure server. No IP HTTP server. No IP HTTP secure server. Configure SSH. IP domain name CCNA security.com. Crypto key generate RSA modulus 10024. Success. IP SSH version 2. Okay, IOU L2 does not support this command, but this is the correct answer. Timeout 90 seconds. IP SSH time dash out 90 seconds. Okay, it's not supported, but this is the correct answer. And authentication retries. Okay, it's not supported, but this is the correct answer. Configure VTY lines to allow SSH access. Okay, line VTY024 transport input SSH. Okay, it's not supporting SSH, but this is the correct answer. Configure AAA authentication and authorization settings. Enable AAA, exit, AAA, new model. Use the local database as default settings. AAA, authentication, login, default, local. And also for authorization, AAA authorization exit default local. Create VLAN list and switches S1 and S2. First of all, on S1, configure terminal. VLAN number 2, name new native. Case sensitive. VLAN 10, name LAN. And VLAN 99, name black hole. Case sensitive. Okay, on exit. S2, the same process. VLAN 2, name new native, case sensitive. VLAN 10, name LAN. VLAN 99, name black hole. Exit. Configure trunk ports on S1 and S2, Fast Ethernet 1 and 2. Okay, the connection between S1 and S2, Fast Ethernet 1 and 2. In my case, Ethernet 01 and 02, the connection between S1 and S2. Okay, first of all, on S1, interface range, Ethernet, in my case, 01 and 02. Switch port mode trunk. Okay. This is the correct answer, but this will work on 2960 switch very good. But you have this message because IOU L2 is like a 3560 switch. So first of all, you need to apply this, the encapsulation, switch port trunk encapsulation.1q, and then configure switch port mode trunk. And native VLAN number 2, switch port trunk native VLAN 2. Remember, the VLAN 2 is the new native VLAN. And prevent DTP. Okay, switch port no negotiate. Okay, remember that this interface is already enabled. Okay, the same process on S2. Configure terminal, interface range, Ethernet 01 and 02, switch port trunk encapsulation.1q. Okay, only on IOU L2 or 3560 switches. Okay, now switch port mode trunk, switch port trunk native VLAN 2. Okay, and prevent DTP switch port no negotiate. Okay, the interface is already activated. Exit. Okay, you can verify this and show interfaces trunk. Okay, Ethernet 01 and 02, native VLAN 2. Show VLAN brief. Okay, the VLANs. Okay, on S1 and on S2 ports 18 and 24 and VLAN assignment to VLAN 10. On S2, 18 is connected to PCB and 24 is connected to ASA. In my case, 03 is connected to PCB and 00 connected to ASA. Okay, only on S2. Okay, 18 and 24, in my case 03 and 00. Configure terminal, okay, only on S2. Interface, range, Ethernet 03 and Ethernet 00. Switch port mode access to prevent trunking and access VLAN 10. The VLAN called LAN. Enable port fast and BPDU words on S2, also on 18 and 24, in my case 03 and 00. Okay, in this same range. Switch spanning tree port fast. Okay, don't worry about this message. And spanning tree BPDU word enabled. Word enabled. Success. Configure basic port security on S2 only on 18, and in my case 03. Okay, 18 connected to PCB, in my case 03 is connected to PCB. Okay, only 18. Exit interface Ethernet 03. Maximum 1 switch port security. First of all, this to enable port security. Now, maximum 1. Remember MAC address, so use a sticky. MAC address sticky. And violation action shutdown. Violation shutdown. Disable unused ports on S2 and assign ports to VLAN 99. Okay, this is the range for unused ports. Okay, if 1, 2, 18, and 24 are in use, the unused ports are from 3 to 17, and from 19 to 23, and gigabit 0 and 01 and 02 on 2960 switch. Okay, but for my case is different. Okay, and show running config. In my case, only Ethernet 00 is in use, 03, 01, and 02. Okay, in use 00, 01, 02, and 03. Okay, in my case, 00 in use, 01, 02, and 03 in use. This disable all these interfaces from 10 to 13, 20 to 23, 30 to 33. Okay, configure terminal interface range, Ethernet 10 to 13, Ethernet 20 to 23, and Ethernet 30 to 33. In my case, these are the unused interfaces. Enter. Okay, disable shutdown command and assign to VLAN 99, the black hole VLAN. Switch port mode access and access to VLAN 99, the VLAN called black hole. Configure loop guard. Loop guard by default. Okay, exit spanning tree loop guard default. Okay, very nice. Configure Dhcp snooping. Enable Dhcp snooping globally. IP Dhcp snooping. Enable Dhcp for VLAN 10, the VLAN called LAN. IP Dhcp snooping VLAN 10. Dhcp trusted interface is 24. 24 because ASA will be the Dhcp server, and 24 is the trusted port. In my case, the trusted port is Ethernet 00. Interface Ethernet 00. IP Dhcp snooping trust. Exit. Okay, but if you will use NetLab, use a maximum limit of 2 when configured basic port security. Configuring ASA basic management and firewall settings. Okay, ASA. Enter. Hostname. Enable. Enter no password. Configure terminal. No. Hostname. CCNA. Security. ASA. Domain name. CCNA security. Domain name. CCNA security.com. Privileged exit password Cisco 12345. Enable password Cisco 12345. User on the local database for administrator console access. Username admin01. Password admin01 pass. AAA to use local database for SSH user authentication for console access. AAA authentication, SSH console local. Okay, use SSH for the console using the local database. Configure interface gigabit 12. 12 is connected to the switch S2. In my case, I'm using gigabit 02. Interface gigabit 02. Okay, interface gigabit 02. Name inside, interface name inside. Oh, okay, it's name interface. Okay, again, interface gigabit 02. Name interface name inside. Okay. IP address and subnet mask. Security level 100. Okay, now shut down. Gigabit 11, the outside interface. In my case is 01, the connection to R1. 01. Interface name outside. Security IP address. IP address 226. Subnet mask 29, that is 248. The security level is 0. And not shut down. Ignore this message, activate the VLAN. Generate the RSA key pair to support the SSH connections. Exit. Crypto key. Generate RSA modulus 1024. Yes. Configure ASA to accept SSH connections from hosts on the inside LAN. Okay, the inside LAN is this. On 192.168.10.0.24. Okay, SSH 192.168.10.0. Okay, dot 255.255.255.0 on the inside interface. Inside interface. Okay, inside interface is permitted to use SSH clients on this network. Okay, the network was configured, but the timeout 10 minutes. Okay, SSH timeout 10 minutes, and use SSH version 2. SSH version 2. Configure the default route. Okay, the default route choose the NetHop IP address 225 is this, the interface on R1, the NetHop address. So the interface will be outside the default route, the NetHop IP 225. Configure ASDM access to ASA. Enable HTTPS server services. HTTP server enable. Enable HTTPS on the inside network. HTTP, okay. 192.168.10.0 255.255.255.0. Okay, this network is permitted on the ASA using HTTPS. It's placed on the inside network. Okay. All HTTP connections on the ASA are secure. Okay. So is HTTPS. Create a network object to identify internal addresses for path, port address translation. Bind interfaces dynamically by using the interface address as the mapped IP. Okay, the object name inside net. Object network, and the name is inside -net. Enter. Okay, and this is the subnet, the internal subnet. Okay, subnet 192.168.10.0 24 255 255 255.0. Okay, finally bind interfaces dynamically by using the interface address as the mapped IP. The interfaces inside, outside. Just not from the inside network to the outside network. Okay, not from the inside to the outside. Dynamic, okay, it says dynamically and says interface, dynamic interface. Okay, enter. Okay, use the space here, not space inside, outside. Okay, not space inside outside dynamic interface. Very good. Modify the default global policy to allow returning ICMP traffic through the firewall. Okay, exit from object and this is the policy map global dash policy dash map global policy. The class is inspection default, class inspection default, and inspect only ICMP. Inspect only ICMP. Inspect only ICMP. Exit, exit. Okay, you can verify, for example, exit ping R1 gigabit 00 209.165 200 225 success. Okay. Also, you can ping 234 the interface on R3. Okay, ping 234 success. And PCC 172.30.33. Ping 172.30.33.3. Okay, the ping to PCC will fail because remember that the some basic policy firewall was configured on R3 and is blocking the pings from ASA to PCC. Okay, so that's why it's failing. All is okay. For example, activate a PC. This Windows PC. Configure the address .11 10.11 10.1 no DNS, but it doesn't matter if you will use any DNS, but IP subnet mask default gateway. Yes, open the command prompt and ping the ASA that is the default gateway. Success. Okay, ping 225 the interface on R1. 209.165 200 225 success. And 234 the interface on R3. Okay, 234 . success. And the ping to PCC will fail because some based policy firewall was configured on R3. Sorry, 172.33.3. Okay, this ping will fail because the firewall on R3 is blocking the ping incoming the LAN. Okay, this is okay. Configure site-to-site VPN. Configure site-to-site VPN on R3 using command line interface. Enable IKE. Okay, on R3. Exit. Crypto ASA KMP enable. Create an ASA KMP policy. Policy number 1. Crypto ASA KMP policy number 1. Authentication pre-share key. Authentication pre-share. Encryption 3DES. Encryption 3DES. Hash algorithm SHA. Hash SHA. Diffie-Hellman group key exchange number 2. Group 2. And configure the pre-shared key. The pre-shared key name Cisco pre-share. Configure terminal. Crypto ASA KMP. Okay, this is the pre-share key. Okay, crypto ASA KMP. The key is pre-share. Cisco pre-share. Okay, be careful. And the destination address is 226. Okay, I am configuring R3, and for R3 the destination is 226 because this will be the Ipsec Vpn Tunnel. Okay. Okay, the tunnel. Okay, address 209, 165, 200, 226. Configure the IPsec transform set. This is the name transform set. Crypto IPsec transform set. The name TRN SFRM set. Okay, TRN SFRM set. ESP 3DES. ESP 3DES hash ESP SHH HMAC. ESP SHA HMAC. Enter. Then exit. define the interesting traffic, the source, and the destination. I'm configuring R3, so the source is this subnet 172.30.30, and the destination is this 192.168.10.0, because ASA is the destination. Access list 101. IP access list extended 101. Okay, permit IP from the source 172.30.30. Use the wildcard, and the destination is 192.168.10.0 with the wildcard. Enter. Then exit. Create a crypto map. The name CMAP. Crypto map. CMAP uppercase. Sequence number 1. IPsec ASA KMP is the type. IPsec ASA KMP. Okay, don't worry about this message. Access list 101, the previous configured access list 101. Okay, match address 101. The peer 226, the ASA 226 is the destination, the peer for R3. Set peer. And use the transform set. The previously configured transform set. Use this name. This weird name. Okay. Set transform set TRNSF RM set. Okay. Enter and exit. Finally, apply crypto map to the interface serial 0 CMAP. Okay, in my case is serial 30. Interface serial 30. Crypto map CMAP. Okay, the previously created CMAP. Then exit. Okay, ASA KMP is on, so it's working very well. And now configure site-to-site VPN on ASA using ASDM. Use a browser on PCB to establish ASDM session to the ASA. When the session is established, use the site-to-site VPN wizard to configure the ASA for the IPsec site-to-site VPN. Configuration parameters include the following. Okay, use this Windows PC to configure the ASA. So you need to use the web browser to access the ASA on this IP address, 192.168.10.1. Okay, open the browser and I explore Internet Explorer and go to 192.168.10.1. Okay, but use HTTPS. HTTPS 192.168.10.1. Enter. continue to this website. Okay, allow down here, allow. Okay, later. Okay, run ASDM. Continue. Okay, continue, continue. I accept, run. Remember your username created on ASA, uppercase, admin01 is case sensitive, and admin01 pass. Okay. Okay, and use a browser on PCB, connect the ASA and run ASDM. Okay, it's HTTPS to Dhcp, use this username and password, accept all, and site-to-site VPN wizard to configure site-to-site VPN settings on ASA. Okay, go to wizards, VPN, VPN wizard, site-to-site VPN wizard. Next. The peer address. For ASA, the destination is 234. Okay, 234. Okay, and you will use the outside interface as exit interface. Outside. Next. Okay, outside network. The outside interface. Okay. The local network is the object created inside network. Use this inside network 192.168.10.0.24. Or also you can use the inside net, but it's used by NAT. So you can use this inside network. Okay. Very good. The remote network is the destination, is this 172.33.0. Okay, 172.33.0. '24. Next. Pre-shared key. Remember the pre-shared key created on R3 is this Cisco pre-share. Use the same. Okay, Cisco pre-share. Cisco pre-share. Next. Accept ASA site host network from NAT. Okay. Accept ASA site host network from address translation. The inside, okay. Next. Okay. Finish. Okay. 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 This error authentication crack. Okay. Allow IKE version 1 and also allow IKE version 2. IKE version 1 enabled, IKE version 2 enabled. Okay, you can go to monitoring and go to VPN down here and VPN statistics. VPN statistics and sessions. Refresh down here. Ping. Okay, nothing here yet. Ping PCB from PCC. This should generate interesting traffic and start side-to-side VPN. Okay, from PCC. From PCC, ping PCB. Go to PCC and ping PCB. 10.11. Success. Control C to stop. Refresh. Now it's very well configured. From PCC, ping PCC from PCB. PCC 172.30.33 and go to PCB and ping. Okay, the ping is failing. Okay. Okay, the iKey version 1 is used. Okay, this fails because the firewall on R3 is still blocking connections. Okay, for example, on R3, and show running config. Remove the song member from gigabit 10 and secure and serial 30. Configure terminal interface gigabit 10. No song member security inside. And serial 30. No song member security internet. Okay, and let's see what happens. From PCC to PCB, success, but from PCB to PCC, success. Okay. But enable again the song member on gigabit 10, song member security inside. And for the serial interface, song member security internet. Exit. Display the ASA KMP and Ipsec SA's sessions on R3. Okay, R3. Okay, verify on R3. R3 show crypto question. Okay, ASA KMP and Ipsec. ASA KMP question. SA security associations. Look at this. The destination is 226, the ASA, and the source is 234. Now, Ipsec ASA packets encapsulated 1627. Okay. Another ping from PCC to PCB. Okay, a long ping. Control C, repeat the command. Now you have 23 packets and 34 packets. Okay, very nice. The VPN is working very well. Verify that the site-to-site session has been established using ASDM from PCB. Okay, go to PCB, refresh. Okay, this is the session. Very well configured. Finally, I will start this PC to verify the connectivity. Start. First of all, verify the trunking interfaces between S1 and S2. S1, show interface trunk. Okay, very well configured. And from PCA, ping PCB. This is PCA. Okay, configure the PCA. Time, netmask 24, gateway 10.1. Okay, save. Re-enable, restart the networking. You need to configure S1 Ethernet 0. Okay, go to S1, show VLAN brief. Ethernet 0 should be assigned to VLAN 10, the LAN, for the subnet 192.168.10.0. Configure terminal interface Ethernet 03, interface Ethernet 03, switch port mode access, switch port access VLAN 10. Okay, ready, and try the ping. Okay, ping to PCB. The firewall on PCB should be disabled. Okay, should be disabled. Turn off, turn off. Enter. Now the ping is successful. Control C to stop. Ping the default gateway 10.1, success. And ping PCC. But the firewall will block the ping. The firewall configured on R3 will block the ping. So from PCC, ping PCA 10.10. Okay, PCC is this. Ping 192.168.10.10. Success. Okay, the VPN permits this ping. Control C to stop. Thank you very much.